Hello, hello, hello. Let me know if the sound works. I think it should work. All right, cool. So welcome back. We're still on the register allocator that we did yesterday. I did some minor refactors, changed some of the code. This I think we already know. What I did was I created these two little functions. I'm not too sure whether I like them or not, but I think it makes the whole thing at least a little bit more readable, because this was just a lot in here. This is fine, I guess. I tried to pull all of this stuff out, and that just gives you a function with 8 parameters. Yeah, not the biggest fan. What I also realized while looking at this code is that handled, as is defined in the paper, right? It says handle where it keeps the intervals that we already looked at. That is actually not read. It is only used to insert stuff. So theoretically, we could remove it. Oh, Connie's here. What is up? Welcome. Nice. Glad you could make it. So yeah, theoretically we could remove handled. I want to keep it in here though, because I feel like it's going to be useful for debugging. And while this register allocator seems to work, I am not yet convinced that I didn't put any bugs in it. But that's just how it is, I guess. All right. Connie, you working? All right. Left ear. Your left ear is perfectly fine. Love left ears. All right. So what I actually want to do first thing, I'm sick of this function. I don't like it anymore. You can tell by this stuff back here. Then this, then this, then this, then this, then this. So what I want to do is I want to create a new folder, and then I call regalloc. It already exists. Oh, I think I created this before. And then I want to move source middle regalloc to source regalloc rs. And that should hopefully work. Let's see what everything says, but it doesn't work. Source middle regalloc. Yep. So what we are going to do is we are going to remove regalloc from our middle part of the compiler. And this, I think, can be removed, because today I thought really hard about whether or not I still need SSA deconstruction once I have my register allocator. I have an idea, a hunch, as how I can confirm this. I read a bunch of papers this morning, notably this one here, and they kind of confirm the hunch, and then they go into SSA deconstruction, here it is, and explain whether or not it's needed. And they also reference the paper Messenberg, who was this guy's Christian Wimmer, I think. Christian Wimmer, yeah. It was this guy's PhD advisor. So they're basically the SSA gang, I guess. Like if you look at, they also have these other papers. They worked on the Java hotspot compiler. Messenberg also has different papers on the Java compiler. And Vimmer now works for Oracle. So anyway, he also references the paper that I used to implement the linear scan algorithm. And as I kind of, suspected, however, they still deconstruct SSA form before register allocation during the construction of lifetime intervals. This is what I suspected, because in the implementation of regalloc, we generate moves for the phi operands, which is close to what we do in SSA deconstruction, where we take the phi functions out and put moves in there. So if you look at these two functions next to each other, ignore the renaming stuff, but basically this is me writing Rust a few weeks back, and this is me writing Rust like what, beginning of this year in March. It's pretty close. So my suspicion is that we're good on deconstruction, but first let's finish moving this all in its own module. Oh hey, MD layer, is it? Wait, it's you, right? Wait a second. Oh. Yeah, it's Matt. Nice. All right. Nice. Happy that you're here. What time is it for you? It's super early, I bet. Cargo test. So memory locations context. Ah, that's interesting. Okay, so we moved regalloc to this, and now in main you can run. We need to say mod regalloc, and then in middle. Yeah, so this might be also our context in middle. Where is it here? Oh boy, 140 errors. Why? Module liveness is a private repo. Why? Because middle pub mod. That's helpful here. Why do we need SS? Wait, why do we need SSA? Oh, in our tests, I see. All right, that's fine. It's just us, so we can make this public. Unresolved import super. Does this need to be super is middle, so we could, can we not move all of this in here? Well done, me. Functions never used, analyze. Functions never used, analyze. Oh yeah, that's right. Let's fix this first. So in the main loop of this compiler, we put stuff in in middle run, and then we say regalloc analyze, and it takes in the context, and it takes in the CFG, and it takes in true, and that has to be mute ref, and that has to be mute ref as it is not declared as mutable. Easy to fix. Oh, the CFG doesn't need to be mutable. That can just be, we don't mutate it at this stage anymore. Mismatch type. Oh, it did expect a mutable. Why is it mutable? Doesn't need to be. Oh, it needs to be. Sure. Sorry. Talking out of my. We need to put move instructions in there, so we do need to modify stuff. Sorry. Regel. Consider changing this to also be a mute. Let's hide this for a second. All right, so down 150 errors. Cannot find macro register IDs. Ooh. Why? Why? Have you added the macro use on the module import? What does that mean? Rust, have you added the macro use? How do I, this is exactly what I'm looking for. Macros within the same crate. Pub crate. What? Pub crate use. So if I go into the helpers where register IDs is defined, and I say register IDs, that works. Does this make sense? You can use assertion. I don't need to change the binding. The name move is defined. Oh. Whew, boy. Whew. Okay, so I do have this. Damn it. Where's assert intervals defined? It's also in helpers. Pub. Okay, let's fix these first and then take care of this naming conflict. Assert intervals. Here we go. Export this. What else? Unused. The name binup is defined multiple times. Must be defined once in the value. Previous definition you can use as. Cannot find. Assert has instruction. Yep. Oh, this is also wrong. All the errors are... No, not all the errors are gone. This is the error. So I cannot export. I don't even know how to read this line. You can use as move ins. No. This one is nicer than... So these are all my shitty helpers that I used to build up the IR in tests. What are the references? Bin up. You know what? Let's rename this and call it bin up kind. And let's rename this one, called move kind. And now, if renaming, oh ho ho, yep. Expected macro. Oh boy. Move kind. Bin up kind. Did we fix it? Run all the tests. Do it. Boom. All the tests are passing. Sweet. All right, so let's do a little quick save commit. and say move reg alloc out of middle to top level mod. Because I've been thinking about this, like, is register allocation part of the middle end of a compiler or is it not? I think it is not. It is the bridge between the middle and the code gen. So I would put it in the mid back, the middle, between the middle and the back end. So let's see. So we move this here. So the next thing I want to do is check whether I'm still live. I'm still live. So the next thing I want to do is take all of these functions and put them in separate files. I don't know how other Rust people do this, but I cannot organize my tests in Rust like I want to organize them. So what we're going to do is we're going to open a file called regalc number instructions.rs, and then we're going to put this sweet little function in here. And then we say, oh, how do we do this? In middle, we need to say pub mod middle symbol table. Yep. So we need to say mod number instructions. And yeah. Task on it, that's not right. We need to create middle context. And then we also want to import this, import create middle place. And we want to import this, create middle param index. Okay, so what's wrong now? Remove the unused import. I can do this. The function is what's the problem? Syntax error, where's okay, just deleted something. Function is private. Aha, okay. Liveness. Oh, compute live intervals uses, yeah. Why does it say function import? Oh, I see. That is horrible, what I did here. The naming. Jesus. All right. Okay, so we did it now. Number instructions. Can I not? I should look this up. Is it not possible to create another file that is in the same module as regalloc in this folder? Because that would be sweet. Where's the test? Where is the test? Generate moves. Where's the test? Numbering instructions. There you go. Boom. And we call it mod tests. Is it mod tests or test? It's this one. Yeah, I want to import all of that. Why does it not work? Use crate. No. Yep. This is the problem. This is also intertwined. Like stuff is calling each other. It's driving me mad. Cannot find function analyze in module. Super. Why does this not work? I mean, what is the complete output? No, SSA. Is SSA? Yeah, it's in middle. Oh, I see. Okay, I see. So this is a macro, and that imports stuff. Or the macro generates code, and the code it generates needs more imports. It also needs IR register ID, for example. Yep. Assert instruction number. This. Yep, we are going to steal this from here. We are going to put it here. And now we extracted numbering instructions. And we just call this run, right? And everything should still work. Cargo test. Nope. Source middle liveness. Source middle regalloc. Alright, this looks better. Oops. And this one here. Yep. This is hacky. Why do we need all of this? Generate moves for live operands. Compute live intervals, time and shape. Oh, I see. This is basically an integration test, sorry. Okay, extracted another function. Oh, you can use a more descriptive name for the test modules like mod reg alloc tests. Thank you. That is good to know. So would it be rusty to say you have multiple of these and you say linear scan tests and then you have, I don't know, joining values tests? That I would like more. Because now I have a single function per file. It's not too bad. Okay, so let's see how far we get. Join values, generate moves. Whew. Honestly, it would make sense to put this one and this one and this one in a module called preparation. Because that is what it does. So that means we would need to change this. And say file not found preparation. And then here in regalloc we rename this and call it preparation. And then in liveness, where we had number instructions, we say preparation. Oh, this is good. Okay. So we could now go in preparation and rename this and say it's called number instructions. And then we have an error. Oops, we also have a Vim error. Bad argument. What did it do? Trouble. What is going on? Can we still run our test and see we're in liveness? Preparation run. Number instructions. Regalloc, line 27. Yep. All right, so now we can move these two also in preparation. Let me restart this. I don't know what the problem is. Preparation, number instructions, generate moves. Gonna move this over here. Put it in here. Where's the renamer? Gonna import this. Import. Yep. Hash map. Haven't imported this. That's uncommon. Import create middle IR var. Instruction kind. What else? Functions never used. Things are looking good. Then we say preparation. Or you could also do mod reg mod tests. I see. Doesn't that get the more mods you have? Doesn't that get super complicated with importing stuff? Probably not more complicated than it already is, I guess. All right. Var. Instruction kind. Renamer is unused. Generate moves. This is a test. Removing it here. Putting it here. And importing this kind of stuff. Oh, wait a second. Nope. That's not the AST. It is this one. Convert function var. Yep, that's because we need to import ir binob and ir var. Anyway, hello security noob 3. Who asked any way to watch past streams? Yes, I think if you, let me try to see if I can find the link. There it is. So this is the YouTube channel. I usually export the videos to there. Cannot find function generate moves for fire operands. Cannot find function generate moves for fire operands because preparation. And is it done? Do all the tests already work? Yep. I need some kind of tiny weight that keeps this microphone down so I can sit here more comfortably. Because this is too high. Don't have a tiny weight though. This would be ideal. Can I not do this? There you go. Generate moves for phi operands. All right. All tests are passing. Is this the, oh yeah, joining values that we need to pull out. And then we go to preparation and add the last. Oh, whoa. This is, we want this here in the tests. No imports failing. But join values, we want to pull out and put in this file. Function is not used. Preparation, join values. Unused imports. Join values. Is it private? Oh. Yep. All right, cool. So now let's see. Let's make a commit and say move Move functions to prepare IR for regalc into own file. So now you can see. Yep. It's funny. Preparation liveness, preparation liveness. And then here we have this macro. Yep. That's not a to-do anymore because in this test we want to disable it. Okay, I see. The other problem I have with my tests is, as you saw, I always build up these CFGs here and then put them through something. In this case, it's this, which is wrong. Here we just need to say super generate moves for fire operands. And this. The CFG. Mismatch types. Oh, interesting. Okay, so that's better. So this test now really only tests whether generating move works. But with number, we can remove those now because we don't number the instructions anymore. Sweet. Middle IR with number, we can remove this. Now that's cool. Then generate moves. So this tests. Yeah. Do we? That doesn't work, right? Yeah. Need a new reference. Okay, so this is generate moves, fire operands, basic CFG. If you're repeatedly generating some input for your test in each test function, you can create functions that generate them inside the tests. Yep. That makes sense. So the problem, well, it's not a problem. What I would really have is some way to say, I have a bunch of test functions and they all test numbering instructions and they grouped together. And And I think the only way is to do this with like a naming convention and say, you know, basic CFG or something. Yeah. Ideally, so I have a bunch of these CFG drawings in, like, you know, if you look at these tests, for example, there you go. So this is a graph. Then I have this one, which is, you know, work of art, let's be honest. Then I have this one. Then I have that one. And I think the one we see on the left, yep, there it is. It's just the diamond shape thing without a sign and entry block. And of course, I have this here too. A little bit different, but it would be cool. Maybe I should do this someday to have like a module that generates these where I can select them and say, give me this CFG. And then it returns this. The problem is if I would pull this stuff out into a helper and say, give me CFG in diamond shape or something, I would love to have this little ASCII art in this test because it makes it really easy to debug stuff when a test fails, to see that thing right next to the failed assertion. But yeah, there's a lot of graphs duplicated here, which is not good. But yeah. All right, so numbering instructions. Super number instructions takes in the mute context, I guess. And what else? A counter. What is the counter? Is it a counter? Is it 1? What did we do here? Analyze, analyze. Counter and then func. Oh, you've been loving it. Yeah, thank you. These diagrams these were a lot of fun. Also, this file, in the one in the middle that I'm scrolling through, is probably the cleanest of all of these test files. It only tests SSA. And that was, yeah. That was cool. That was good programming. F. All right, that's cool. So can I say this? Yeah, then I would need to import all of this stuff again. Or use super. No. Oh, okay. Super. That's ridiculous. No, I need to say this one. Doesn't run the tests though. Oh no, this breaks my Vim test run at cursor. Wait, let's leave it for now. Okay, so then super wrong. Where else is this used? Analyze. It's used here in joining values. Yep. And the joining of values does all of it. It says mute CFG and it takes into context. Yes. Does that still pass? Yep. It would be much better if we could have SSA in here. But then I would need to do it by hand. So we only need to do this. Okay. So now all of these tests only do what they need to do. How did I make the SSA test so readable? Put the instructions in. So we had this. Oof, that's not readable. Why Rust format is hard to tame. Is that not possible? Nah, come on. That would have been nice. If it would keep this on one line, this would be So much nicer to look at. Jesus. Fair enough. Let's do this here so it's consistent, this file, and then we try to see whether the register allocator works. Old len, alright. Oh, it doesn't work here. What kind of formatting is this now? All right, let's see. Cool. Did we move stuff around? Clean up, reg alloc, preparation tests. And pushing it up. And pushing it up. All right. So now, let's take a look at our register allocator. By the way, I have new wheels on this chair, and I really don't like them. So now you know. Now you know why I can't. I'm sitting here like this. Can't chill. Reg alloc, analyze. So, ugh. So this sucks. Right? Hello, Indie Monkey. Nice of you to join us. So, what if we go in preparation and we put a function pubfn run? Didn't know you're a Twitch streamer. I wouldn't put it on my business card. I did some streaming or do some streaming, but it's mostly to hold myself accountable. Try removing mute here. Oh, it is already. Do we have time to pitch the project? The project, as in what I'm working on. Yeah. So the really 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 the really short version is what you're looking at is a toy compiler that I started 1 year ago and 1 year and 4 months ago, just to hack on something in Rust, and it is. I'm not interested in language design. I'm only interested in the implementation. So this implements a compiler for a tiny language called Toucan that looks. Let's take a look in our codegen test. That looks like this. The keyword is called func. We have main. We have types. We have for loops, print string. We have a runtime in C, and it generates x86 code. So if we look at target, yeah, this is the code it emits. So if you look at codegen, we for loop, no increment. This code here that I just selected, this one here, is this one. It ends up as this. And if I run it, what this test does is it outputs these numbers and this word. And so yeah, I've been hacking on this, and here's what it does roughly. So we have, of course, I don't know why we need this. Yeah, I haven't read from files yet, I think. So we have a parser, of course. Then we check for the errors. Then we have a middle end of the compiler. And what that does is it turns the compiler into SSA, the code into SSA form. So it has a name resolver that checks which names are defined where. It has a type checker that checks, does the return value of a function check the declared return type, for example. Then we build an IR, which is a control flow graph. And then what else do we have? We eliminate dead blocks, which is the shittiest version of dead code elimination possible. That is only there because I did not properly implement it in here, and this was easier to do. We lower the IR, where we take out string literals and replace them with calls to the runtime. We then construct the SSA form of the IR, which is where I spend a lot of time this year on, the beginning of the year. And then we deconstruct it. After this middle stage, we now have the register allocator, which is new and it's basically unused. And then at the end, we have the code gen stage, and the code gen stage runs and outputs assembly code and says, I'm going to create an assembly thing, and I'm going to start a text section, and then for each function, I'm going to do emit assembly code. And then we return 0. And that's it. That's the project. And if you look at my to-dos of this project, I'm here. Oh boy, we can check this off. Look at this. Nice. We can check it off. Add lots of tests. Whew. Use allocated. So you're making compiler using Rust for programming language you're making. Correct. And the goal is absolutely not to create a programming language that others can use, or to create something interesting in programming language design. The goal is only for me to play around with Rust and to see, I wanted to learn what is SSA. you know, how do I build a control flow graph, stuff like this. Yeah, it's a learning project. And if you look at, let's say this, yeah, so yeah, I learned a lot this year. So immediate representation, SSA, cogent, this is a sucker, liveness analysis, dominance frontiers, blah blah blah. Like there was a lot of cool stuff this year in this project. All right, so we checked this off. We should add more tests, of course. But let's take a peek at, and it's in Rust, of course. It is, yes, written in Rust as we all say. Does this now work? Did it run this? Yeah. Okay. What do we do next? What I want to see is, oh, you're not distracting. That's not a problem. So I want to show you something, or I want to show you something. First of all, this is shit. So I want to change this from a function to something like funcode. We have this I have this in Cogent, and we build one of these for each function. Yeah. So I still don't like this code here. Can we not remove this last one? What is this? Prepare. Yeah. So we only have one test for register allocation. Yep. Come on, microphone arm. Stay down. Can I maybe do something like this? And wedge my phone in here. No. Where are we? Let's maybe make this a little bit easier to read. I'm this close to writing an ASCII parser to just write CFG by hand, so I could do this or write this in text. Which other compilers do, right? Like LLVM and stuff, they have parsers for the IR, which kind of decouples the whole thing, which is what's worrying me here. Okay. So say, let's try something here. Let's create a helper function. Generate diamond shape book example. That is a function that returns context, a CFG, and a func ID. Did this just work? No. Func. Oh, it's block func ID. Block func ID. There you go. Struck with this. Okay, so linear scan diamond shape. Say let context CFG func ID. Oh, that was too much. Let context CFG func ID generate diamond shape book example. Ah, damn it. Yeah, that is the problem that I also ran into. So these are identifiers, and I want to be able to access them in my assertions. We could, of course, make this a macro, I think. Macro rules generate Why does this not work? What is unique about Rust? That's a good question. The memory model. That's unique about it. Its combination of features and performance profile, if you want to call it that. Why does this not work? Can I not simply... It doesn't work, right? Because... it doesn't work. Because Rust does not... If you use a macro, it sanitizes the names, so these would all be unique names. That's why I can't find them here. Ugh. All right, let's put this back here. Worth a try. Performance in what way? Rust has pretty good performance, but also at the same time provides relatively high level language constructs that are often called zero cost abstractions. So for example, this stuff here, where you say you have a hash set, you iterate over it, you chain that iteration with the filtering over another hash set, then you filter the elements of both, and then you go over the result of this. Like all of this, if you do this in Ruby, which is what it reminds me of, or in Elixir or in JavaScript, this the performance of this would be higher than if you would just do it in a single loop, because all of these are loops. Like, I'm glossing over details, of course, and I might be out of date on the optimizations. But in Rust, if possible, the compiler will take all of this and optimize it into one loop. So you don't have to say, you know, I run over this, then I run over this again, blah, 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 blah. So the way I would describe Rust, or how I see it in my mind nowadays, is that Rust is C++ with trying to have a ease of use of, you know, say a Ruby or Python, but that's probably the wrong description, I guess. To me, like I talked about Rust yesterday, but and I don't want to rant, it's just one thing that I really value is simplicity and minimalism. And, you know, I value this from an engineering perspective, I guess. And I also value this on an aesthetic level. And for example, Scheme I find really beautiful. I really like how minimal Scheme is. And I also like the simplicity of Go, which, you know, people often hate, but I see the trade-offs, and I do think interesting engineering decisions were made, good engineering decisions were made. And Rust, I don't think shares these values with me, you know, which is fine. It's just, it's a huge language. It's huge, and it's really complicated or complex. And I often bump against this because, you know, this is my third attempt to do Rust, and I've worked on this compiler for one and a half years nearly, and it has nearly 10,000 lines of Rust code. And I would still say I only touched the surface of the language. I barely know what I'm doing. And, that says more about me than Rust, I guess. But I can say that I'm not getting super excited about the language. I really like the tooling. I like Rust Analyzer. I like the type system. But I wish it were a bit simpler. Yeah, ran over. All right, so before we should we maybe do this before we end up just talking about Rust? Wouldn't you say Python is more minimalistic? Not sure. I'm not a big. I don't know Python that well. Might be a little bit simpler. But yeah. Ensure that if a register has been allocated, the intervals that use that register do not overlap. So let's just try and do this. So for place reg. Yeah, Lua is pretty minimalistic. Lua is nice. Lua is really nice. I have, let's see, I have clones Lua. I have a bunch of Lua versions checked out here. So if you look at Lua 1.1, which I looked at, this is it. Like, look at this. Look at this. This is Lua 1.1. And it's granted, they use the EC for lexing, but if you look at, where is it? Is it in out? Provide lex. Opcode. Execute to give an opcode. Where is that called? Oh, right. It's isn't it executed as it's parsed? Parse Lua code and execute code. It's part of the yak, whatever this is called. Yeah, it's not a lot of code. Then Lua 532. That's a bit bigger. Yeah, but it's still, same amount of lines that my toy compiler has. Well, a little bit less, but whatever. The main problem of Rust is the dev time. You make a lot of run debug scratching head loops. Yeah, I guess. What drives me a bit mad, when people talk about Rust is that they recommend it universally and say that, oh, Rust is the best language. I learned Rust, and now I only want to do everything in Rust, and you should use Rust for this, and blah 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 blah. And I think the people often say Rust has a steep learning curve, but I think it's not only a steep learning curve. I understand Rust to, I think, a certain extent, so that I'm not learning the stuff anymore. But Rust requires you to rethink a lot of the stuff that you wouldn't do in any other language, and you need to do a lot of things in order to get something done. And I don't think that is worth it. This in the same vein that it's not worth it to write every script in C++ or C for optimal performance, right? Because it's a lot more work. You need to do memory management, blah, 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 blah. And I think Rust's ergonomics is real cost that people underplay. Full plays, so this is actually interesting. So what the allocator does is it puts in registers the places that all the registers are assigned to. The thing is, though, we need to kind of reverse this and say let reg places and say it's a hash map where we map cogent reg to a vec of place. And then we say reg places entry oh, wait a sec. Oh, okay. Entry reg or insert with vec new push place. So now we go over all 4 reg places in reg places, and now we need to say 4p in places iter and say 4o in places iter filter. Is there no standard lib thing for permutation? Rust pair all elements in a vec. That's not what I want, is it? No. Grofsal, yeah, I agree. You wrote, I feel like Rust requires you to write code in a Rustian way. You can't write C-style Rust as you can with Python or other languages. You need to write and design your program from the perspective of it being written in Rust. And if you start fighting it, it will make your life a misery and force you to do it the Rust way. I agree. And I think the cost of that is exactly what I meant. It's a very real cost. And people underestimate it. If p overlap o panic Oh, the interval. The interval. Oh, TJ's here. What is up, TJ? Welcome to the greatest channel in the world. I still don't know what a POG slide is. The fact that that this works. Let's see if this works. All right. Connie has been DMing everybody that you live. Nice. I do have better TTV. Why don't I have this on this? Do I not have this on this computer? I have it on this computer. But it doesn't. What is POG slide? Do I type in POG slide? No. Oh my god, this is being recorded. You control what emotes show up on the Better TTV website and then add emote to the channel. What? So I need to sign in to Better TTV. I can't do this right now. I'm doing it now. You got me. Okay, I added it to the channel. Wow. I don't know what's next then. Top emote, that's cool. There's a cat jamming. Yes, your Linux pen was really good. It was really, really good. Let's see it. This is really good. What's the highest rank in all of open source? The Linux kernel. So good. Which brings up the bigger question, why is it written like this, right? English is my second language and this always tripped me up. Good tweet. May it go viral. And blessed be your Twitter input field. All right. So what we're doing here is that's stupid. Let's turn this into a little macro rules. Let's say assert reg intervals, no overlap. Wow. That rolls right off the tongue. And you say, give me the context, give me the mem. I think that's it. Then we say mem is this. And then we say context is this. And context is this. And this is context. And this is context. And then we say assert on second. We say assert reg interval has no overlap. And we put in the, I think we put in the context and we put in the mem. Technically, we don't need it down here. Okay, can we make somehow, can we break this? If available registers filter, let's do this. Boom, okay, but this is not what we want. I want to make sure that my test here works. Ha! All right. Blah, 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 test panicked, blah, 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 overlaps with this, and both are assigned to Rx. So it says 4001, 3000, 0, which are these two. They are assigned to these two registers. And if we take a look up here, 4001 lives from here to here. And 3000 lives from here. Where is it? That doesn't make sense. Oh, they do overlap. What the? Oh, okay, yeah. So these are coalesced intervals. So here you can see the interval for 3000 is 5 to 7, and that obviously overlaps with 6 to 14. All right. Assert. So what I now want to do is run this, make a commit. Oh yeah, I need to undo my breaking change. You wrote Christmas cards, and one of my friends says he's a kernel. It is the dumbest spell word. No, there's a few more dumb. Isn't there another military rank? Admiral General. Oh yeah. No, teacher, before you run this. This is also not the best spelling, especially not this. Yes. In the UK, it's pronounced lieutenant. That's ridiculous. All right. So we got the test to pass. Sweet. So now what I want to do is I want to add a to-do here and say, let's print all of the registers. Yep. So what I want to do, I want to see what comes out when I replace these virtual registers in the function with the real registers. So let's see where our block func thing is. Block format with predecessors. let's do this. We go to our helpers, and then we say pubfn debug print func assigned registers, and we say context f block func, and then we take this, and then we say debug func and f. Cannot find. All right. So now, let entry is f entry unwrap, and then we import this. Format ID set, where does this come from? Oops. Yeah, let's copy and paste it for now. Func. It's private. Ah, man. IR format with predecessors. Print on. Block ID. And then we say for preds. Print on M. Print on. For ins in block instructions. Okay, unexpected token. Why? Oh, block terminator. Okay, let's see. Let's see what this prints. Of course it doesn't work. Private function. Successor IDs. How often do I press this? What else? Unused var. What else is broken? Okay, so now we can say with real registers. So basically what I want to do now is I want to not print the instructions as they are, which would be instruction would be in this one here. And then you have let's do this. So we still don't have a really nice way to go from a place to the real register. We need to find its representation and then find the register, or whether it's on the stack. But yeah, oh, we also need to put mem in here. Memory locations. Yep. So let's go back to where we were and do this and say match ins number, print nl, print nl, ln, not nl, ins target, ins kind, ins target, ins kind. And now we say we're gonna print this again. But now we're gonna switch out and say real target is context place wrap of inst target, and then mem get reg and say add wrap. Let's take this here and we say do this and say match mem get wrap this some reg or offset. We can also just get location, self, place, option, codegen, reg, or offset. And we say match self, get reg, place, some reg or offset reg. Otherwise we look into self stack get place into Let's see. Whew. Interesting. By the way, this is super hacky code. Please don't judge me on this. So somehow our register allocator doesn't find real targets for some of the values. This one, 4002. Why not? What? Print? No. What the fuck? Oh, I see. I see. Okay, so there's this problem here where we do join stuff together, but the interval only has one place. So this is a data structure problem. Down here it says there's no real target for rep 4001, even though the interval here is 4001. But somehow in the register is this one. Interesting. Okay, I really gotta hop off now though. So this will be the next task. Add assertions and broken test run of regalloc. Because this is something we need to work. We need to this needs to work. We need to translate all of the instructions to use real memory locations. And I already suspected that something here was off in how these values are joined together. And that is, well, the next thing I gotta work on. I don't know if I'll be streaming this or not, but I will most likely stream again this week. I'm not sure if it's tomorrow or on Thursday, most likely Thursday. But yeah, I'm not even sure whether this is interesting to others because it's mainly just me poking around at stuff. I don't have background music. But yeah, I need to get this to work because I need to say, or I want to be able to say wrote a register allocator this year. But this should be doable. All right. And with that, I will most likely see you next time. Bye-bye.